In this video, I'm going to be talking about the fundamentals of software testing, what testing a software really means. Hi guys, welcome to my channel, and if you are new here, my name is Geraldine. I am a QA engineer and an agile coach. On this channel, we will be exploring the exciting world of software testing, QA, and agile. We're going to be discussing the following topics. What is software testing? Why is software testing necessary? 7 testing principles, types of testing, and test levels. Software testing is the process of verifying that the actual software product meets the expected requirements and to ensure it is defect-free. The purpose of software testing is to identify errors, gaps, or missing requirements in contrast to the actual requirements. Testing is necessary for the following reasons. Defect identification. Testing helps identify defects or errors in the software early. Early detection of these issues allows developers to address them before the software is released to users. Verification and validation. Testing verifies that the software is implemented correctly according to specifications. This is what verification means. And testing validates that it meets the user's needs and expectations. This refers to validation. So testing helps us verify and validate that the system works perfectly. The third one is user satisfaction. Thorough testing helps ensure that the software meets user expectations, leading to increased user satisfaction. A reliable and high-quality product enhances the reputation of the development team and the organization. Product quality. It is an essential requirement of any software product. Testing ensures that quality products are delivered to customers. Continuous improvement. Testing provides valuable feedback on the software development process. Analyzing test results helps teams identify areas for improvement in coding practices, development workflows, and overall software quality. Cost savings. Detecting and fixing defects early in the development process is generally more cost-effective than addressing issues later in the software lifecycle or after deployment. Testing helps prevent costly post-release defects and maintenance. Testing shows the presence of defects. Exhaustive testing is not possible. Early testing, defect clustering, pesticide paradox. Testing is context dependent. And lastly, absence of error fallacy. The first one is testing shows the presence of defects. The fundamental purpose of testing is to identify defects and or discrepancies between the actual and expected results. The goal is to uncover as many defects as possible to improve software quality. So basically, we have to try to find defects whenever we are testing. It's one of the most important software principles. Exhaustive testing is not possible. It is impossible to test all possible input combinations and scenarios for software application. Instead, testing should be planned and executed based on risk analysis, business priorities, and critical areas of the software. Early testing. Testing activity should start as early as possible in the software development lifecycle. Early testing helps identify and address defects at the initial stages, reducing the cost of fixing issues later in the development process. Defect clustering. A small number of modules typically contain the majority of defects. This principle suggests that focusing testing efforts on these high-risk areas can be more effective in finding defects. Pesticide paradox. If the same set of test cases are executed repeatedly, the effectiveness of these test cases diminishes over time. The pesticide paradox emphasizes the need to regularly review and update test cases to ensure that they remain effective in finding defects. Testing is context dependent. This means that the context matters when you're testing. If you're testing an e-commerce system, it's definitely going to be different from an identity management system. So you have to consider the context, the type of software you're building before determining what test to perform. The absence of error is a fallacy. This means that finding and fixing defects does not help if the software is unusable and does not meet the user's needs. We have two types of testing: functional testing and non-functional testing. Functional testing involves testing the functionalities of the software to ensure it matches requirements and specifications. We have types such as unit testing, integration testing, system testing, acceptance testing, regression testing, sanity testing, confirmation testing, and ad hoc testing. Non-functional testing, this is a testing done to check how well the system performs under various conditions. Types include performance testing, load testing, stress testing, usability testing, and security testing. There are two test levels: static testing and dynamic testing. Static testing is the process of examining software documents and related artifacts without executing the actual code. Static testing techniques include reviews, checklists, static analysis. Dynamic testing involves the execution of the software code and the evaluation of its actual output against the expected result. Dynamic testing techniques include white box testing and black box testing. In the next video, we're going to be discussing these techniques in details. If you enjoyed this video, then give it a thumbs up. Please leave a comment if you have any questions or feedback. Thank you so much for watching. Do check out for upcoming videos.